Hi everyone. In the previous part, we already found the final velocity of combined block after collision. Now, in this part, we will use that result to derive expression for maximum force acting during the collision. Let me explain you the question. Block A, when collides with block B, it exerts force on block B given by expression Ft is equal to Fmax sine of at. And collision take place between time t is equal to 0 to time t is equal to Tc. So we have to find this Fmax. So in AP physics, always starts with basic principle. And here fundamental principle is that impulse is equal to change in momentum. But for you, I will derive that expression. So initially it was given that m and 6m were moving with velocity 2v naught, v naught. After collision, this combined mass was moving with velocity 4v naught by 7. This we had already solved. Now please see here. Force is given by dp by dt. I am multiplying this dt here. So this f dt will be equal to dp. And then I am integrating it. So this is integration. Here we have to apply limit on time, and here we have to apply limit on momentum. So at time t1, momentum was p1. At time t2, momentum was p2. So this dp is nothing but p2 minus p1 after applying limit. So this is impulse, which is equal to change in momentum. Now we will apply this basic formula to obtain this Fmax. So our body is this B. So what is initial momentum of B? Initial momentum will be equal to 6m v naught, but of course with negative sign. Mass into velocity, but negative sign because it is moving towards minus x direction. Sign convention we have already discussed. And now this 6m was moving with velocity 4v naught by 7 towards minus x direction. So what is final momentum? Final momentum of block B will be equal to 6m is mass into 4v naught by 7, of course with negative sign. So what will be change in momentum? So change in momentum will be equal to final momentum minus initial momentum. So final momentum is minus 24 m v naught by 7. This is final momentum. Minus initial momentum is minus 6 m v naught. So from here, minus 24 m v naught by 7. Minus of minus will become positive. So plus 6 m v naught. So I am multiplying both by 7 and dividing it by 7. I will get minus 24 plus 42 by 7 m v naught. So this will come out to be 18 m v naught by 7. And this should be equal to, as per this relation, it should be equal to integration of ft dt, and then we have to apply limit. Limit is from 0 to tc. See, in the question itself, they have mentioned that limit has to be applied from 0 to tc. So this is our expression. And what was ft? Ft was given to be f max sine of at dt, and limit is from 0 to tc. This will be equal to 18 m v naught by 7. Since f max is constant, it can be taken out. Integration of sine of at dt, limit 0 to tc, should be equal to 18 m v naught by 7. And you should know integration of this, which will be equal to minus cos of at by a, and then we have to apply limit 0 to tc. This is f max, which will be equal to 18 m v naught by 7. Those who don't know, I am writing formula for them. Integration of sine of ax dx is equal to cos of ax divided by a plus some constant. But here we have applied limit, so we don't require constant. What you can do, you can change limit with this negative sign. So this f max and cos of at by a, and limit has been changed. This is 0, this is tc is equal to 18 m v naught by 7. So f max by a, and now I will apply limit on time. First I will write t0 here, so it will become cos of 0 minus cos of, then I will apply limit on time, that will be tc. So minus cos of a tc will be equal to 18 m v naught by 7. So f max by a, cos of 0 is 1. 1 minus cos of atc is equal to 18 m v naught by 7, which implies f max will be equal to, I am multiplying this a here, so this will be 18 m a v naught 7, and I am dividing it by this expression. So 1 minus cos of a tc. So this is the final answer for f max. So it's very important. You should understand that we started with physics principle. We have showed integration clearly, and then we have connected it to momentum. This is exactly how AP graders award full marks. So if you follow this structure, you can solve any force time question. Practice this and you will gain a huge advantage in exam.